Hello everyone, good afternoon. Thank you for participating in today's webinar. So we will let more and more participants as they enter, they can continue adding whenever they're available. As you might know, today's webinar is about sand and permanent mold castings for non-ferrous alloys. So we'll quickly jump into it without wasting too much time. Today, from our side, I'm anishay. I'm a director and take care of business development at Exclusive Magnesium. On the call as well is Mr. Akshay Raj. He is the head of production from our side, and Mr. Sunil Raj, who is the founder as well, is available for any questions that you might have. Just a few rules for today's webinar. All questions, we encourage you to try and stay muted at all times. If you have any questions, just mention it in the chat box. Whenever it's relevant, we'll pick it up and we'll answer those questions for you at the end of the webinar mostly. But if there's anything relevant that comes up on a particular slide that we can answer, we'll just mention it. Try and stick to generic questions so that it's valuable for everybody attending the call. But if you do have any industry specific questions, we'll try and take that up at the end, or send you the answers for that, or schedule a call afterwards to answer those questions specifically. Yeah, and if there is any technical glitches, which I'm estimating usually for every webinar, we have some technical glitches for sure. So if that does happen, please be patient. I'm sure if you have any audio issues or if you're not able to see the screen, just log out, log in, you'll be fine. Try and stay off video so that the clarity of the voice is also better. If everybody can quickly mention whether they're able to hear me clearly with a yes in the chat box.
Yes, you are audible.
Okay, perfect. All right. So we'll move next. So today's webinar will be covering the different types of non-ferrous alloys. If there's any, and then we'll talk about sand casting and permanent mold castings, and how specifically the advantages and disadvantages of these processes are. I'm sure most of the people here are engineers and they understand these, but we'll quickly cover it so that if there's anybody who does not understand that can also understand. Post that, we'll cover 8 key questions that both manufacturers and clients should ask each other and talk about before they start their engagement. This reduces a lot of friction and challenges at a later point. So that's what we have for today. We'll talk about how you can get into how you can start an engagement for sand casting and permanent mold if you want to immediately after this call as well, and we'll cover Q&A. So there's obviously a lot of non-ferrous alloys that that exist. So everything ranging from nickel, copper, zinc, aluminum, magnesium. But we've decided that for today's, just to make it efficient with time, we are going to cover two alloys, two metals specifically. One which is extremely common in India, which is aluminum, and the second one which is just making a late entry into magnesium, like late entry into India and mainstreaming now, which is magnesium. So, but the principles that the economics and the advantages, the disadvantages, and the key questions that we're going to cover are going to be relevant for everyone. So that should not be a challenge. Right. Quickly getting into it, I'll just tell you a little bit about magnesium. Most people must have heard magnesium as something which exists in the body or as a supplement, but very few companies in India understand magnesium as a potential structural metal. So it's a mainstream alloy globally. It's extensively used everywhere in both sectors. But in India, due to the cost difference between aluminum and magnesium, it's been not very well used. But more recently, with advanced machinery coming in, like electric vehicles, consumer electronics, this has been used more and more. 90% of magnesium in the world is extracted in China and is imported by other countries. Why is magnesium important? It's the lightest structural metal and it is almost 40% lighter than aluminium. So it's for that reason it is used in performance critical lightweight parts. And recently we've seen a lot of companies transition their aluminium designs, their steel designs, their plastic designs, their titanium designs into magnesium for several reasons. First of all, it has excellent EMI, EMC shielding properties. It is 100 times better damping properties. For example, all steering wheels in India are made out of magnesium because it because of its ability to absorb shock. Even phone enclosures and laptop enclosures nowadays are made out of magnesium, and that improves makes it more dense resistant and does not disturb the electronics inside. Magnesium also has very good thermal conductive properties. It's almost very similar to aluminium in a lot of ways in terms of mechanical properties. So in terms of strength, that's where we are. It has the best strength to weight ratio in all structural metals. Right. A lot of people have a misconception as well that magnesium is corrosive, which is not true. Magnesium over the years, so many years of being used globally, has been refined to a point where it has become where people have been able to create alloys of magnesium which don't corrode easily and are as good as stainless steel. And but also with changing of compositions of the magnesium alloy, you can make it corrosive on demand. Give you an example: medical implants. Nowadays, we're making a lot of corrosive medical implants so that they can dissolve in the body on demand, right, over a period of time, as much over a period that you determine. So those kind of use cases also has been coming up with magnesium. If you are looking at building uh, machinery and equipment which is handheld or has to be mobile or wearable or is energy efficient, which is in our experience all modern machinery and equipment is falling into this, you should seriously consider magnesium as a potential non-ferrous alloy. To understand how magnesium is categorized, you can see over here, you will see uh, the, the alloy designation, which is AZ91E. It is the most commercially used alloy globally. Um, how it is determined, and most magnesium alloys will be categorized in this way. The first letter of this alloy, A, stands for the highest alloy content. Now these letters keep changing. So the highest alloy content is number one. The second highest alloy content is number two. And the correlating how you understand what element that is mentioned on the right on this table. So A stands for aluminium, Z stands for zinc, and 9 and 1 are the respective percentage of that element in that composition. So 9% aluminium, 1% zinc. E is the revision of the alloy. So like I mentioned, over the years, magnesium has been refined several times to perfect the composition to make it more non-corrosive. E is the current composition that is being used globally. And F is the temper condition. So whenever people are talking to you about magnesium alloys, they will talk to you about ZE41 or AM50. These are the ways that magnesium alloys are categorized. I'll send this later on this presentation so that you can have this handy, and you can also understand different types of magnesium alloys. Aluminium, there's not much that we can talk about aluminium. I think India understands aluminium alloys extensively. India has a very robust aluminium ecosystem and very good expertise in all commercial alloys. So aluminium is obviously a very ductile and a lightweight metal. It is usually used as a replacement for lightweighting purposes as well as a steel alternative. It is produced abundantly in India and is never in shortage in that sense. also used for parts which for enclosures, structures, and thermal use cases in our experience. The major wrought alloys that are common is 6061, 6063, 7075, and the cast alloys are like you can see LM2, 5, 6, 9, 10, 13, 24, 25. So LM6 and LM6 and LM9 are the most commonly sand casted or permanent mold alloys in the context of sand casting and permanent mold. Right. So I'll touch up a little bit for anybody who does not understand sand casting, and we'll move on. So casting, as you might know, is nothing but filling a cavity with molten metal. Now, to fill that cavity, like if you see this image over here, it's a representation of what a sand casting might look like. You'd see there's a line in between. This is called the parting line, and there are two boxes that are always used. These boxes, there's a pattern that is put in between to create a cavity, and the mold around the cavity, if that cavity is surrounded by sand, it's called sand casting. That's majorly it. Create this cavity. Every sand casting will have a runner, which is through which the metal is poured. It fills up the cavity, and the riser indicates whether the cavity has been completely filled or not. So that's the basic logic. The pattern to create this cavity, which is packed within the sand, can be made. We usually use wood and metal, but there are other other companies which use plastics, different forms of engineered plastics as well, and polymers for further very complex designs. That's been coming up, 3D printed molds as well. So patterns as well. So next is based on the alloy itself, the mold and the pattern dimensions are determined. So if the metal alloy has determining based on the shrinkages that are required and the cooling rate of the process that you're following, the different molds and patterns are designed. This is obviously done by your manufacturer itself. They are the ones, depending on your alloy and the process, they will determine what the flow rate will be, the cooling rate will be. All this is the manufacturer's job. So they will help you make this design, and they will also help you determine the pattern design, dimensions, molds, everything. This is a picture of like this is typical size sand casting that we usually do. This is a 500 kilo casting that is being done. The top box has been removed so that you can see the pattern inside. If you see on the right, on either side, you'll see these boxes. This is where through which the metal is being poured. And you can see the path of the metal as well. It will go through here and fill up this whole cavity inside. The top box will have the runner, so that which indicates that it is completely filled, and that's when the pouring is stopped. Since this pattern, since this mold has been made out of sand, over a period of time, it will take a certain amount of time for this to cool. Sand will take a longer time for it to cool, and therefore, probably by the next day, this will be removed, and then you can start, doing the secondary processes that might be required for this casting to be finished. Okay, quickly on the advantages and the disadvantages of sand casting. Sand casting is usually a low to medium volume capable process. We'll get into the exact numbers right after this during the question stage. It has a very quick turnaround time. So from the point that you finalize the design, you've decided to do tooling for sand casting, which is usually in metal or wood. It hardly takes any time. Within probably a month or a month and a half, or maybe maximum of 2 months, you'll have the part in your hand. So it has a quick turnaround time in that sense, and it can be done even quicker. So that time is this is the quickest process in that sense in terms of castings. It has low cost of tooling. So since it's done in wood or through aluminum, when it's a machine pattern, the cost of tooling is relatively low. The lowest tooling comes in sand casting, and this is only ideal for prototyping or for really small batches of production. I'll tell you probably the size, volumes, and all of that at the later stage. Even say when you're prototyping and you want to revise the design itself, sand casting makes a lot of sense because you can very easily revise the design and you can try it again, do another batch. So that's a good advantage for early stage companies, early stage products. So and there's also no size restriction in that sense. So we've done castings which are as small as 250 grams, and the highest we've done is 2.5 tons. So in terms of size, sand casting can accommodate fairly huge sizes as well. So that's a major advantage. Disadvantages, usually these require, since you want the metal to flow easily through the sand and fill the complete cavity, the majority of the manufacturers will account for a higher thickness than required, so that wall thickness than required, so that to give you the near net finish later on, they will use machining to give you the finished part. So sand casting will have a higher level of machining than any of the other processes, and because it's a skilled process and uses extensive labor, it is also an expensive process. So only when you're doing prototyping or a very small batch of production, or like say maybe your product can afford to have a expensive component, like say defense can. Most of defense components are done through this process. So it completely depends on that as well. Permanent mold. So permanent mold casting, or some people also call it gravity die casting. This process is very similar to sand casting, but the only difference over here is that the mold which holds the cavity is made out of metal. So this is not sand, this is metal. And as you can see over here, this is this can be open and closed and can be clamped during the time of pouring. And the cavity that has been created in the metal is done through machining. So that's why the die of this die will also be expensive in comparison to the sand casting pattern, right? Yeah. Similarly, the shrinkages, the cooling rate is quicker in sand in permanent mold, because it's made out of metal and metal absorbs the heat quickly, and the thermal conductivity happens fairly quickly. So this, in that sense, you can create a lot more parts in this, and all this will be calculated by a manufacturer and tell you exactly how the die should be made based on the alloy you choose. All of that, you should expect the manufacturer to do all that process. Okay, just another point on the basics. This is just a picture of how the cast iron die usually is made out of cast iron. So this is the cast iron die over here, and it's machined inside to create the cavity. You pour it from the runner. You'll see in the riser whether the metal, whether it's completely filled or not. As you can see over here, the metal is poured, it's filled, it's opened, the part is removed, and it can be redone several times. So there's no, whereas sand castings have a limited, if you make it out of wood, you can only do a maximum of maybe 25 parts to a sand pattern, or like a wood pattern. So the repeatability is what permanent mold offers at higher value. Advantages of permanent mold: since the metal mold is able to absorb and assist in the thermal conductivity of the heat escaping the mold, the properties that you get from the part are significantly better than sand casting. That's one. Permanent mold is also a more thermally controlled process, and there are lesser chances for casting defects in this process. You'll also be able to achieve a near net shape in this process. You can do as good as maybe plus or minus 0.2 mm, the kind of tolerances that you could expect. Not all parts can completely. Are there times where you can just cast something, move the runner riser and polish it a little bit and just put it to use. There are a lot of parts that you can do that, but there will be some parts where you will require a little bit of allowances here and there, and maybe a slight machining on one side of the section might be required. So that's one thing. Since it's a repeatable process and the die cools fairly quickly, you can do significantly higher RE volumes in this process. If you wanted to include like a different metal insert in this process during the process itself, for example, there's an electric vehicle wheel would have a steel strip on the inside, which is then attached, you attach magnets to it. So during the pouring process, you just put the steel rim inside and then do the casting process, and you don't have to do any secondary process to insert that steel rim at a later point. So that's just one example of how that could be useful. In terms of disadvantages, honestly, in our experience, the tooling is cheap. It might be 5 to 10 times cheaper than pressure die casting. So it is relatively more expensive in comparison to sand casting, but I would call this a cheaper tooling. But if you're comparing sand casting and permanent mold, this is a more expensive tooling. This will have slightly longer lead time. We'll get into the lead time immediately, but slightly longer, maybe about a couple of weeks or 2 to 4 weeks longer than sand casting in terms of tooling. And fewer non-ferrous alloys are compatible for this process. So, like I mentioned, LM6 and LM9 probably are good alloys for over here, and AZ91 and AZ80. All these alloys are better for sand casting processes. Permanent mold processes. Permanent mold is also limited by its shape because how the metal die is used. So it is limited by the biggest machining center you can probably find to do a part like this. So that is a major restriction. And the tolerances. So pressure die casting, the kind of tolerances that you can expect in pressure die casting is not something that you can expect in permanent mold. So that's one negative. Okay. So we'll get into the 8 key questions that all manufacturers and clients should be asking each other, and that would solve a lot of the problem. The first question, first of all, is sand casting or permanent mold casting, or what process suits you, is what is your annual usage? I think this should be disclosed upfront. Sand casting, the sweet spot for us has been one unit to 1200 units in a year. And if you are under that, you might consider sand casting as a process, right? In terms of permanent mold, customers come with 500 to 35,000 units per year. And if you're within that range, it makes sense to do permanent mold. It all depends on the customer's product stage. If you're just at the prototyping stage and you've not finalized the design, you don't know whether it's going to go into production, you might as well just do sand casting, right? So you have to talk, like the client and the manufacturer have to talk to each other to understand what is the product stage and what kind of tooling makes sense. For example, recently we had a customer who came in who wanted like about 20 units now, but they anticipated like 1,000 units later. So later in the same year. So we recommended to them that probably a good alternative would be to do a aluminum pattern in sand casting, because even if that 1,000 units didn't come in later, we would still be able to do 50 more, 100 more, 200 more in a viable way, and that pattern could still be used for larger volume. Whereas a wooden pattern would have been lost its value in like 25 units at max. So those kind of discussions customers and manufacturers should have with each other so that we can determine what is the right alternatives within sand casting and permanent mold as well. And sometimes it just makes more sense to just go to die casting itself, pressure die casting. Okay, what is the end application? this is, most manufacturers will not get into this, but it is a very valuable, very valuable discussion to have with your manufacturer, that where will the casting eventually be used, what is the actual use case, and once they understand that, even they will be able to tell you what kind of regulatory information they would require. Like, say, is this supposed to be IP rated? Are there any approval standards? Is there any testing standards? Or is there any of those that come into play? So all those are important. Yeah. So at a later point, you should not understand that, okay, you made it out of sand casting, but actually a rolled plate would have made more sense, or extrusion would have made more sense. Those kind of decisions you will be able to make only when you have that conversation up front. And also, once we understand the use case itself, there are a lot of alloys that usually people are not aware of. And once we understand the use case, we'll also be able to give you an understanding of what better alternative you could go for a better performance of the product, of the casting. Or for example, recently we had a robotics company that came up, and they have a robot which does on a single charge, is a mobile robot, so it moves around across and on a charge. So if you have mobility as one of the requirements, I would say that it's always better to go with magnesium for a heavy component, because that would significantly improve your runtime, and that's something that they can consider whether that's a priority for the customer or not. But that's the one place where we can also come in and tell you that, okay, maybe there's a better alloy that you could use if that's your end use case. Third, what is the size of the piece? So in sand casting, the sweet spot that we found is about 250 grams to 1,000 kilos. We've also done parts which are 1.5 ton, 2.5 ton. So that's not, but majority of the sweet spot is within this range. For permanent mold, anything between 50 grams to 150 kilos is something that can be managed. And it's very important to have that conversation with your manufacturer itself, understanding whether the size that you're talking about, is that something that they can manage themselves? Is that a stretch for them? Because in sand casting, even say a 250 kilo casting or a 750 kilo casting, or in permanent mold, even a 75 kilo part can sometimes become a challenge for manufacturers. So it's important to understand the factory size that you're working with, and can they accommodate it and easily, or is this going to be a real stretch for them? Fourth, what is the history of the part? So is it an existing component? Is it an optimized part, or is it a brand new part? Once you understand that, a lot of you can ask a lot of more questions about the part itself. Because if they tell me that it's an existing component or an optimized component, I would immediately ask them, are you moving processes, or have you faced challenges with production previously? So and that would also indicate a lot of other things that would come out immediately. I'll give you an example. Recently, we also do extrusions. So a company came to us with lots of extrusions, and they basically they wanted to do those. But when we asked the same question to them, we understood that all these extrusion products will be then bolted together to make a single large component. And we were able to guide them that instead of doing 7 different or 5 different molds for extrusion, you could do just one die for permanent mold and consolidate all those parts in a single part. So part consolidation is one major element that usually happens when you have these conversations with customers. Another one would be when you talk about it. Recently, we had these electric vehicle companies who are importing wheel rims from China, and one of them said that they are facing a wobbly wheel. Like after 2 to 3 months of use, they are seeing that the wheel starts wobbling during use. That's attached to the vehicle. So we understood the machining priority that exists, right? So the point where the vehicle is connected with the steel rim, that is a high tolerance machining requirement over there, or else this would eventually lead to a wobbly wheel. So those kind of things come up when you have conversations like this. Schedules and lead time. So a lot like every product has its timelines, and that has to be shared with the manufacturer, and they also have to be on the same page. Uh, Another thing that you should always look for tooling. So even for sand tooling, anywhere between 2 to 4 weeks, and sometimes even 6 weeks. It's a very complicated component, and even 6 weeks it might take for sandcast tooling. And for permanent mold, you should anticipate anywhere between 4 to 8 weeks for the tooling to be made. So that has to be blended into your product schedule as well. Um, Another thing is you should ask the customer itself that when does the clock start ticking. Most manufacturers would expect the clock to start ticking after the PO has been released. But if they are able to share with me that within 3 months I have to deliver the product to my customer, irrespective of how the PO is, the die has to start being made. Everything has to happen so that the 3 month deadline can be met. And the customer and the manufacturer both have to be on the same page when that is happening. So, right. And yeah. Question number 6. What are your finishing requirements? There's a certain kind of finish that you can expect directly out of the mold. Right? For sandcasting, you will expect a lot more machining allowance that has been given. Whereas in permanent mold, you have to talk to the manufacturer to understand that are they able to achieve uh, uh, the finished requirement, near net requirements, and where are they giving allowances and for what reason. So once you understand for what reason they're giving allowances, you'll also understand the amount of machining that would be required that would add to the cost of the piece. So discussing all these things will give you a better idea as to what to expect in terms of price point, and the amount of machining that will be required to meet the near net finish. Uh, in terms of coating possibilities, you should talk about what is, in terms of your end use, what is the coating that you might require. So there's a lot of options: anodizing, powder coating, painting, chromate coating. All these are applicable for magnesium, aluminum at least. So those have to be discussed upfront, or do you just want it to be non-coated? Or whether coating is being done by you, the client itself. And are there any other secondary processes? Are you doing sparking, machining? Are you doing grinding? There's a lot of other things that you would expect the casting manufacturer to do for you, and that has to be completely outlined and made clear. 7. This is, have you budgeted for tooling? I'm surprised, but a lot of new age companies usually don't do this part really well. So you have to have a budget for tooling, and once you have a budget for tooling and you've decided the process, whether it's a permanent mold process, die casting process, sand casting process, whatever it might be, you want to discuss with the manufacturer whether this will be amortized, meaning over a period of years, a year or a couple of years, you want to amortize this over the production itself, or whether you'll be doing a upfront payment. The manufacturer should ideally always give you an incentive to make an upfront payment for a die by giving you a discount on that on the die itself, right? So, and the third thing you should talk and discuss about is what needs to be the life of the tool. So, what is how long is this project time frame, right? So, if the service period itself is going to be about 15 years for the component that we casted, you would require some certain amount of spares to be made over a period of 15 years, and the die has to be preserved for that duration and kept in good condition. Right? So maybe you'll come back to me 3 years later and ask me for 500 more, 1,000 more units, and maybe after 11 years ask me for just 5 more. But that has to be discussed so that you understand, okay, what is the product demand, what is the service period, and what is the life of the tool that you are expecting. And they can give you like build alternatives, which makes sense. Because you can do a lot of playing around with materials for the die itself and see whether something better comes out. The last question is, do you have a defined quality quality plan for this part? So what are the relevant quality standards? Are you following ASTM, AMS, etc.? So there's a lot of these standards that at raw material stage, at casting stage, at mechanical property stage, you can refer to these documents and you can tell them that this is what I'll be referring to ensure that you've given me a quality product. You would also want to understand the approval criteria of the customer's customer. So a lot of, like say, for example, a drone company would come to me and tell me that they'll get the part done, they'll send it to the customer, and then the customer will bring up something that, okay, we don't want different, like they'll come up with a different quality metric. So if we know that upfront, then we can recommend a better way of the process itself. We could make changes. We could probably recommend a better process for you itself in some cases. So maybe forging makes more sense. Maybe machining it out of roll plate would make more sense if that's the requirement. Things like that. The next is, what kind of third party or in-house testing would you want the manufacturer to have for the approval of the part that has to accommodate it and given along with the casting itself. Fairly simple. I think most people understand this. And the last one is inspection matrix. If you don't, I think what stages of the casting you want to witness yourself? Is it the testing? Is it the pouring? Is it what stage do you, as a customer itself, want to witness? What stages do they need test certificates? All that has to be put into an inspection matrix. And where do you want CMM? Everything. Basically, all those things have to be put into an inspection matrix, and before they move into the casting process or even tooling process. And if anybody who does not have these or don't have that much clarity on the quality approval plan, then we can also help. The manufacturer itself can help in a lot of cases because they work with so many clients. They understand that what would make sense for what product, and to keep the cost of the product at the level that we need while getting guarantees on the quality. So that the manufacturer can always tell. Right. So these are the major 8 questions. If there's anything that we missed out, please do mention it in the chat box, and we'll cover that and probably add that if we find it relevant for a future session with a different bunch of people. So what's your annual usage? What is your end application? What is the size of the piece? What's the history, the schedules, the timelines, the finishing requirements, the budget for tooling, and the quality plan. So these are the basics, the absolute basics. There's a lot of smaller questions that will come up, obviously, but these are the basics of what you should be talking with your manufacturer, or as a client, you should be thinking about when you're thinking about your product. Okay, just quickly for 2 minutes, I wanted to cover what we do. For the past 25 years, we are a foundry, and we deal with specialized castings for the past 25 years. We've been doing non-ferrous castings. We've worked with 100+ brands ranging from CEAT, Mercedes, ISRO, DRDO, you name it. We probably worked with very big names of Volvo. There's a lot of names, big names that we worked with over the years. And we are certified for AS 9000, 100B, ISO 9001, 14001, 45001. So we are a legit, we follow all the processes that are required. We are also the only company in India which has approval, airworthiness grade casting approval for magnesium castings. But we regularly do defense and industrial, and even for automotive, we give a lot of castings. So that's just about us. We just want to, as an organization, we're just trying to use the power of lightweight materials to improve performance and to help people create performance and energy efficient machines of the future. So that's our vision. That's why we talk about non-ferrous, and we see a lot of advantages in lightweighting that come up in non-ferrous itself. What we can do for customers ranges from high pressure die casting, gravity casting, centrifugal casting, machine parts, sand cast, in parts, extrusion. We also make roll plates, forging. We are now experimenting with closed die forging, but we already do open die forging and sheet bending. If you are at an early stage of your product, I would encourage these processes that we are currently able to help customers with. Sand casting, extrusion at a very low volume, machining, 3D printing. These are the ones that I would recommend. And if you've reached a certain level of batch production or you've reached serial production, then obviously high pressure die casting, extrusion, and permanent mold castings makes more sense. So these are what we are able to offer. In terms of design, if you have an existing design, we can completely redesign that for new materials if you need. We can help you optimize that design to make it further lightweight or in any way you want to optimize the design. We can also help you custom design any component for your specifications or do all the analysis that are needed. So in terms of design, we also have that. All right. So what next? We have, you can immediately after this, we'll do a Q&A. But if you don't have a question right now and comes up later, you can always write to me at sales@exclusiveMagnesium.com. You can send us a drawing or a step file for us to do, give you a budgetary estimate or a manufacturing feasibility. We do things for free. We have we encourage more and more people to send us these so that we can evaluate their designs. And if you want, we can always schedule a call directly with your team to help you explore any form of non-ferrous or just understand the design priorities and make the right recommendation. Or if there's something that we can help with, directly we'll let you know. Okay, let's go directly to the questions. Ritvik, do you have questions?
Yeah, there's one in the chat right now.
Okay. Okay. So magnesium and aluminum have similar EMI/EMC. Magnesium is slightly better because you can achieve the similar EMI/EMC shielding with thinner walls, thinner wall thicknesses. So that's a major advantage. In terms of measuring criteria, so I can probably share a few research papers or documentation about the EMI/EMC shielding specifically between magnesium and aluminum in separate documents. I think I'm also using this as reference from the research and documentation like publicly available. So I'll share those documents right after this call. So the second question is about what is easier to cast, aluminum or magnesium, and both are exactly the same in terms of castability. They are both easy to cast. Magnesium can be cast in thinner walls, with thinner wall thicknesses. That's an advantage for magnesium. And in most cases, you can actually use the exact same die for aluminum and magnesium. So that's not a challenge. Even in pressure die casting, even for sand casting, the same pattern can be used. Even for permanent mold, the same mold can be used. Yeah, because shrinkages are similar for these parts, both these metals. So the next question is, which is a more durable component, forging or casting? So I think durability completely, I feel like it will depend on your usage, but forging definitely has significantly higher tensile values. So forging has significantly better mechanical properties overall in every aspect. Okay. Do we have any other questions? Okay. I'll wait on the call and see if there's any questions that are being shared. If not, we also have a bunch of FAQs that customers do ask us about this process, everything from coatings to machining and stuff like that. So I'll share a list of FAQs that we have over the years accumulated from customers, and I'll share that document with you, including the ones that have been shared over here. But if there's anybody else has a question, you can ask us right now. If you don't have any further questions, you are free to leave the call. That's all we have for today. So at any point, if you don't have any further questions, you can drop out. And but you can also write to us. I'm just sharing my email ID right here. So you can write to us on this email ID and we'll answer you within 24 hours. Any industry specific also, we're more than happy to answer.